so excited to see me again. It's great. All right, here we go. We're going to look at graphing some equations using standard form using a table of values. Now, if you have started working on the must-do practice problems, which is totally fine if you decide to, if you started working on some of the must-do practice problems, you might have run into a little thing where you needed to sort of create a table of values that you essentially were putting in X values and finding corresponding Y values given this certain situation. The situation you're looking at in your book is t-shirts versus caps, and you're playing around with these numbers, and some of the numbers you're probably finding like, ooh, if I put this number of caps in, I'm not able to figure out the number of t-shirts very easily, or I get partial number of caps or something like that with your table. Well, we're going to run into that same situation here. Here is our situation. We have x plus 2y equals 10. First, I always want you to ask yourself, is this truly written in standard form? So I want you to know that, like, is this a value a number that is a positive integer, and this has that hidden 1 up in front of it with that mathematics, that has that hidden 1 there. So yes, it has a positive integer up in front. These other two numbers, are these negative or positive integers? Or so do we have just integers here? Do we have negative numbers or positive numbers? And yes, we do. So great, it's written in standard form. You're going to create a table of values similar to what we've done with slope-intercept form. We did this at the very beginning of this unit. So this is no different than what we've done before, except our equation is formatted slightly differently. So our equation, I'm going to stick that way up here. I'm going to say x plus 2y is equal to 10. And I'm going to put that into my table. Now, I'm going to be really thoughtful about the x values I use this time. So in the past, I've always said, always use these 5 x values, -2, -1, 0, 1, 2. And you can start there and like hit the ground rolling. The thing is, you'll probably find with some of these, if you use certain x values, you get out y values that are not very easy to graph. And while that's okay and you can deal with that, it might be hard if you have just a sort of basic graph that you're doing and you can't necessarily find third of units or quarter of units very easily. So I want to show you why I say that. I'm going to put 1, the number 1, into this equation, and we're going to see what happens. So if I put 1 in for x, I have 2y is equal to 10. 1 plus 2y equals 10. I'd have to subtract 1 from both sides, get 2y is equal to 9. 9 is not easily divisible by 2. I mean, it kind of is. We know it's 4.5, but it's not like a nice whole number. And while we can handle having 4.5 for y, it's again hard to graph. So if we were to do all this, divide by 2 on both sides, we get x is equal to 4.5 or 9/2. So we got 4.5 out of there. And I can erase all this. And so now we have a point 1, 4.5. 1, 4.5. It's kind of awkward, okay? So I just want you to be thoughtful about what you might need to think about in terms of what is happening here with this coefficient in front of this y, and what is happening here with our constant. 10 and 2 are easily divisible. These are both even numbers. So I want to keep that going. If I put an odd number in for x, I will turn this odd, and then I have like a lot of decimals that I'm having to deal with. And while decimals are totally within our wheelhouse as 8th graders, it could be a little frustrating overall to deal with that like constant like 0.5 all the time. So instead, I'm going to pick these numbers. -4, -2, 0, 2, 4. I still have that nice pattern of negatives versus positive numbers and 0, but I know that these these evens are going to play a nicer role in this equation overall. So I'm now going to put these numbers into this equation. I'll put -4 plus 2y is equal to 10. -2 plus 2y is equal to 10. And I'm going to start solving for y. If you want, you'll be able to skip ahead if you don't want to see all this work happening, because it's going to take a little bit, but you're also welcome to watch it. So -4, I'm going to deal with this. I'm going to add 4 to both sides. That means I have 14 is equal to 2y. I have to divide by 2. 14 divided by 2 is 7. -2, I need to add 2 to both sides to balance this out and get that to turn into 0. So I have 2y is equal to 12, so y is equal to 6. 0 is going to play no role in this, so I get 2y is equal to 10, so divide by 2, I get 5. I'm going to subtract 2 to make this 2 disappear. So I get 2y is equal to 8 when I balance this equation out. Divide by 2, and I get 4. 8 divided by 2 is 4. I'm going to subtract 4 from both sides, so I get 2y is equal to 6. Divide by 2, and I get 3. So now I have these coordinate points. I have -4, 7. I have -2, 6. 0, 5, 2, 4, and 4, 3, that I can now graph and plot onto this graph over here. So now I'm going to do that, and I should be well on my way. -4, 7, 1, 2, 3, 4, 5, 6, 7, -4, 7. It's going to be here. -2, 6 here, 0, 5 here. And I can see that I was like right in line with that 1, 4.5. It's exactly what I want to see for this line. You can totally see that it's linear. However, it's just kind of messy. It's a little messy to graph that one. And we have 2, 4 and 4, 3. And now I can connect the dots, and I can see the rest of this line develop. Cool? Isn't that neat? It's so neat. So cool, I'm done. So that is how we graph with a table of values given a standard form equation. Our next problem is going to have us graph, but what I'm going to show you is this cool like hand trick that you can do to sort of think about intercepts. And intercepts are a nice way to potentially graph with standard form equations. They're pretty cool. All right. Watch this next video, and I will see you later. Bye.